Okay, let's go ahead and take a look at factoring some special things that happen here. We are going to look at a couple that you might already know from Algebra 1. The last piece of this video is going to cover something that you might not have touched on yet in Algebra 2, but it's going to pop up eventually, I promise. So let's go ahead and get started. What I have here is just a binomial. Looks pretty easy. I mean, they're both got a factor of 3 and they both have a letter m. So I know I can factor out a 3m. So remember, I'm just kind of dividing here. 27 divided by 3 is a negative 9. So I'm going to just hold off on that 3m. I'm just going to see, just to check if this is factorable. Even though a middle term is missing, maybe it could happen. So remember, for the bottom part of my x, I did 4 times negative 9, and that's a negative 36. Now, usually at the top, I would put the b value, but there's not a b value, so I'm going to put a 0. Now, are there factors of 36 out there that would combine to make a 0 pair? Absolutely. A negative 6 times a positive 6 is a 0 pair when you combine them. So just like in the other videos, I'm going to rewrite that 0 pair in my work. I'm going to turn this into a grouping GCF problem. I'm going to go ahead and factor out a 2m out of the first set. So that's going to be 2m minus 3. And over here, I'm going to factor out a 3. So this is going to be matching 2m minus 3. There's my first set of parentheses, 2m plus 3. And my other one's 2m minus 3. That was factorable. Actually, what was happening here is this was a difference of 2 squares. If you notice, my factors and parentheses are almost identical. They just have different signs. Also, if you notice the first terms in the parentheses, that 2m times itself is 4m squared, which is what we had. And then those last two terms, that positive 3 and that negative 3, that positive 3 times that negative 3 is the negative 9. So let's continue. So basically, what we have here is we're going to call this a difference of 2 squares. Notice I do not have a middle term. A middle term would be like a 0 pair. It would cancel out. So when we have a difference of 2 squares, it will always factor to something that looks like this. Notice that the the expressions in the parentheses almost match. They just have different signs. And what goes in the parentheses is just going to be the square root of what you started with. So what's the square root of x squared? It's just an x. What's the square root of 49? It's just a 7. Just drop those numbers in the parentheses. Just don't forget to change the signs. So x squared minus 49 is x plus 7 and x minus 7. Let's go ahead and take a look at this example right here. This is nothing, honestly, but let me prove it to you. Let me show you. So I'm going to go ahead and draw my work. Remember, I'm going to prove to you it's not going to work. So remember, we don't have a middle term, so I put a 0. The bottom term would be a times c. The a value is just 1, so 1 times 36 is just 36. So all I can do with that is just make 6 plus 6, which is not 0, or negative 6 plus negative 6, which is not 0. So this is absolutely prime, which means you can never, ever, ever factor a sum of squares. Don't let the teacher trick you on that. Okay, so let's see what's going on with this trinomial. We have x squared plus 4x plus 4. I'm going to go ahead and draw my graphic organizer. I just did a times c, which is going to be at the bottom piece of my x. The middle term is also a 4. Let me list all the possible ways to get a 4. Notice that all the 4s are positive, which means all of the numbers have to be the same. So we're going to use a positive 2 times a positive 2. And I'm just going to go ahead and turn this into a GCF problem. Notice my first term and what matched are identical, which means, guys, we really need to get comfortable using exponents here. That's going to happen a lot. When you are factoring a trinomial and both of them end up being the same exact factor, only write it once and use your exponent. And this is actually called a perfect square trinomial because you get the same factor, it's just squared. Let me show you the rule for a perfect square trinomial. So the first term is squared and the last term is squared. The middle term of a perfect square trinomial is the root of those multiplied together doubled. Let me go ahead and put in some numbers. It might make a little more sense here. So that's an x and that's a 4. And then I'm going to show you kind of the rule of what's going on here. Oh, and by the way, I just want to point out that it could be positive or negative for a perfect square trinomial, but the last term is always positive. So I can have a plus or a minus in the beginning, but the last piece always has to be positive. And that's how those are going to be factored. So instead of like drawing my X organizer and just trying to find factors that match, I'm going to use the rule for a perfect square trinomial. I'm going to find the root of 4, which is 2. I'm going to find the root of 25, which is just a 5. And I'm going to multiply those together. When I multiply those together, that's a 10. But in order for it to be a perfect square trinomial, that middle term has to be 10 doubled. And what is 10 times 2? It is 20, which is exactly what we have. So in order for me to factor this, I'm going to take the root of the first term. The root of 4 is just 2. The root of 25 is just 5. And I drew that plus sign because the 20 was a positive. That's it. That's in factored form. Notice this has a term missing, and it's a minus sign. It almost looks like it's a difference of 2 squares, but 2's not a perfect square. Also, you should notice that both of these terms are even. Anytime you have any expression where all the terms are even, you need to factor out a 2 for sure. So let me go ahead and factor out that 2. And what do you know? We have a difference of 2 squares because 144 is 12 times 12. So remember, a difference of 2 squares has the opposite sign in the middle. They don't have the same sign like a perfect square trinomial does. That's it. That's the answer for that. I should have boxed that in, but I forgot. Okay, so let's check this one. 4's root is 2. 9's root is 3. Let's multiply those together. 2 times 3 is going to give us a 6. Let's double 6 and we get a 12. Which is going to be the middle term. It's a negative 12, and that's okay. That still works for us. We're just going to have a minus sign in our parentheses. So we're going to take the root, which is 2, the last root, which is a 3, and notice I have a minus sign in the middle because once again, that 12 was negative in the original problem. So hopefully you're noticing here, this is not the correct answer to this problem. I'm missing my exponent. Do not forget your exponent or you won't factor it correctly. Okay, so here's the piece that you might not have discovered yet or covered in class. These are sums of perfect cubes. So perfect cubes are always going to be a binomial, and for perfect cubes, you can factor whether there's a plus sign or a minus sign in the middle. This is a plus sign, so I'm going to go over this quickly. And here we go. So the first thing that you do is you cube root the first term and the last term. The cube root of the first term is just x. And then 3 times 3 times 3 is 27. So when I cube root the 27, it's going to be a 3. Notice I wrote a plus sign. I wrote a plus sign because that was in the original problem. That's not all that we're doing here. The other piece for a perfect cube is going to be a trinomial. I also want to mention when you factor perfect cubes, you never look back at the original problem. In fact, I'm going to move my paper up. I just want to talk about x plus 3. So remember, we have a trinomial coming up. You remember trinomials have 3 terms. The first term is going to be x squared. We're squaring it. The last term, you notice I wrote a 9. That came from 3 times 3. Notice right now I'm also pointing to that plus sign. I'm pointing to that plus sign to remind myself I have to write the opposite of a plus. The opposite of a plus is a minus. So whatever you write in the first set of parentheses, the other set of parentheses is going to get the other sign here. But the last term is always positive because remember, we're squaring a number. 3 times 3 is positive 9. A negative 3 times negative 3 is a positive 9. So the last term's always positive. Now, all I'm missing is the middle piece. So easy. To get the middle piece, we're just going to multiply the binomial terms together, 3 times x. That's it. 3 times x is just 3x. There you go. That is in factored form. By the way, I want to point out that this trinomial, you're not going to be able to factor it further. So once you get to this process right here, you are safe to box that in. Okay, now this is a binomial and it has 2 cubes. This is a difference of 2 cubes. This is factorable the same exact way. We're going to cube root both of those terms. The cube root of x to the third is x. The cube root of negative 8 is negative 2. And just like in the previous example, we don't look back. We continue on from this binomial. So I'm going to draw my parentheses and go ahead and write the first piece for the trinomial, which is x squared. And remember, a negative 2 times a negative 2 is a positive 4. Now, my binomial has a minus sign, which means my trinomial has to have the opposite of that. So I write a plus. Notice I'm going to write a plus right here. And that's going to be how you factor cubes.